Hello friends, so in today's question, mass of block B as shown in figure is small m and that of cart C is capital M. Coefficient of static friction between the block and the cart is mu. Neglect friction between the wheels and axles and the rotational effect of the wheels. Show that the maximum value of force F such that the block does not slip over the surface C has the magnitude given by this formula. And B part, determine the minimum value of F which must be applied on B block such that it will not slide. And the C part, what is the minimum acceleration of the cart so that the block M does not fall. Okay, so the same question, have the different configuration of block B. Here this is block B, this is C and having the mass capital M. Okay. Same here, capital M, this is with small m, and this as capital M and this way of small m. Same question, have the different position of small block M with respect to C. So first we are going to do the A part. Okay. So in the A part, we are going to find out what will be the maximum value of force on the B block. Okay. So we can say that, let us draw, this is block B and this is block C, and force is being applied, whose value is given as F, is being applied on block B, and there is a friction between block B and C. The coefficient of friction is given as mu. So block B will try to force block C towards right side, and let us suppose that force of friction is given as Fr, and we are going to have equal and opposite force that will be acting on block B because of this Fr in this direction. That will be also equal to Fr, and we assume that as it is said there is no slipping, it means B and C should move together, and when they move together the common acceleration of both B and C is given as A, and which is also towards the right side. Okay. So we can say that, let A be the common acceleration of B and C when they move together. So we can represent this entire thing with a common one block rather. Okay, and this is given as mass small m and this is having mass capital M. So this will be M plus capital M. A force F is being applied on it, and this is A is a acceleration. Okay. So from here we can say that force, the applied force F, then the applied force F is equal to M plus capital M multiplied by A. Or from here we can find out A will be equal to F upon M plus capital M. From this also we can draw a conclusion that this acceleration will be the maximum acceleration such that both B and C move together. Okay, or we can say B do not slip on C. this is the maximum acceleration such that B do not slip on C. Okay. B do not slip on C. From here we can also say that the acceleration of block B, if it is represented by AB, will be equal to A. Okay. And also the acceleration of block C, which can be written AC, will be also equal to A. Okay. Therefore, if this is above block B and it is an acceleration of AB which is equal to A for this side, so we have our force F, and there is a FR downward direction, and it is going to have mg, and there will be normal. Let us suppose that NA in the upward direction. Okay. And similarly for block C, its acceleration is equal to AC, and which is equal to A. So this is our block C, and we have our FR. It is moving towards right side with the acceleration of AC, which is equal to A. So from here we can write that FR will be equal to, its mass is given as capital M, so this will be M into AC, which is nothing but M into A. And we already know value of A. We substitute it here, we get FR is equal to M into F divided by M plus capital M. And we can find out the value of FR from here. From this equation we can say FR will be equal to mu into NA. NA will be equal to mg, so we can say this will be mu mg. So we can also say that under no slipping condition, we should have FR should be less than or equal to mu mg. That's a limiting value of the friction. So we already know FR, we put it here, we get M, F, M plus capital M is less than or equal to mu mg. From here we can say that F is less than or equal to mu mg M plus capital M divided by capital M. If we solve it further, we can get F is less than or equal to mu mg, and you get M plus small m divided by capital M, and this is the required answer, that or with no maximum value, so we can say F max is equal to mu mg 1 plus m divided by capital M. This is our maximum value of force for no slipping condition. So F max is maximum value of force such that block B does not slip on block C. So this completes part A. Now we are going to solve for part B. Okay. So in part B, we are required to determine the minimum value of F which must be applied on B such that it not slide. Okay. So in part B, so we have this is block C and we have block B, and force F is being applied on it. Its mass is given as small m and its mass is capital M. So we are going to have mg in the downward direction, and there will be a frictional force Fr in the upward direction if it is sliding in the downward side. And we are going to have a normal n. So if we say that there is acceleration A, okay, for the acceleration A, we have F minus N will be equal to ma, okay, where A is the combined acceleration, okay, for the acceleration A, and we can also draw this here. So we have Fm plus capital M, a force F is being applied on it, and A is its acceleration. So we can write that F is equal to M plus capital M into A, or we can say acceleration A equal to F M plus capital M. So you put the value of A, you get F minus N is equal to M into F divided by M plus capital M, or from here we can write normal. We take F as common, so this will be coming as 1 minus M plus capital M, or we can say a normal N will be equal to F M plus capital M. And if you want that block B should not slide, then the vertical forces should be balancing each other, or rather we can say block B should be in equilibrium. Okay. Say for block B not to slide, P not to slide, all the vertical forces should be in equilibrium, which basically means that Fr should be equal to mg. Fr should be equal to mg, and we can find out our Fr. So we can say our Fr will be equal to mu into n. We already know value of n, and we write this mu, this will be Fm m plus capital M. We substitute it here, we get mu Fm m plus capital M is equal to mg, or we can say our F is equal to mg divided by mu m plus capital M. We can solve it further. We can say F is equal to mg by mu, and this will be coming as 1 plus m divided by capital M. So this is our minimum value of F. This is minimum value of force F such that force F applied on block P such that it won't slide, such that it will not slide. And now we come to the C part. In the C part, what is the minimum acceleration of the cart so that block M does not fall? Okay, so this is cart C. It is already traveling with the acceleration alpha, and we want to find out the minimum acceleration alpha such that M does not, block B rather, does not fall. So we have C. This is block C, and we have this block B having mass M, and its mass is capital M. It is given that they are traveling with acceleration alpha, and there is a normal n, mg in the downward direction, and we are going to have Fr in the upward direction. So these are the various forces acting on it. You can clearly see that for equilibrium, okay, or rather we can say if alpha is the acceleration for alpha as an acceleration, we have n is equal to m alpha, and Fr, we can find out that Fr will be equal to mu n, and n will be equal to our, so this will be m alpha, and we want that this block should not fall. Okay, so it means for block B not fall, the value of Fr should be greater than or equal to mg. Fr should be greater than or equal to mg. Under that condition, the block B will not fall in the downward direction. So we already know value of Fr. Fr is given as mu m alpha greater than or equal to mg, and we can cancel out m, so we can say alpha is greater than or equal to g by mu. So it means this is the, to ask the minimum value of acceleration, minimum value of acceleration for which block B does not fall. It does not fall. This completes all the three parts. So in this, all the three parts, we only considered one important aspect, that is value of friction Fr. Okay. And this helped in solving us all the parts which were based on value of Fr and their relative portions. Thank you.